Welcome to Elixir Wizards, a podcast brought to you by SmartLogic, a custom web and mobile development shop.
This is Season 15, The State of the Stack. Join us for conversations about how the software development landscape is evolving.
Each episode examines observable shifts, what's driving those changes, and how people in the community are adapting in response. Hey everyone, I'm Charles Suggs, software developer at SmartLogic.
And I'm Emma Whamond, also a software developer at SmartLogic. And we're your hosts for Season 15, Episode 5. We're joined by Saša Jurić, Elixir mentor and author of Elixir in Action. Today we're talking about code quality, how AI is changing the way we write, review, and maintain code, and how our workflows are shifting to adapt.
Hi Saša, welcome back to the show.
Hey, thank you for having me.
Yeah, always a pleasure. I'm sure most of our listeners are familiar with you and at least some of your work, Elixir in Action and other things, but for a refresher, could you give us a quick overview of your history and what you've been focused on recently?
I've been coding, I wrote my first Hello World some 35 years ago, started working professionally as full-time 25 years ago, been doing a lot of object-oriented programming, C#, Ruby, C++ before that, JavaScript, of course. And then in year 2010, my work took me to Erlang. And then basically this is where I turned to this beautiful functional concurrent programming. A few years later, I started dabbling with Elixir, and that's my perfect stacks ever since. And I haven't been doing much of anything else since then. For the past, let's say, 7 years already, time flies. I've been working as an independent. I try to avoid the word consultant, so I call it a mentor thing, where I help teams adopt Elixir or work with Elixir more professionally or more reliably to produce more reliable code. Yeah, that's roughly the idea.
Before we jump in, I wanted to start somewhere more foundational, because I think it actually sets up everything else we're going to talk about. You've spent a big chunk of your career thinking about and writing about what makes Elixir code maintainable. So I wanted to start there. In your opinion, what's the difference between correct code and good code?
Right, this is, I suppose I could burn the entire time budget just answering that one question. So just stop me if I start to ramble too much. So, right, we have this code. What is code? It is first and foremost like an executable specification. And out of running this thing, the program, we basically then get our desired functionality. But of course, it's more than that. It's a medium of communication. Up until recently, it was a medium of communication exclusively between humans. And these days, we also have artificial humans in the loop. But it's the same thing, right? So the code communicates how the author solves the problem. And this is a very important thing because as we work with the code, right? So because software is, of course, changing, we do a lot of changes in our programs over time. We have to understand what goes on in there. What's the current state of the code? How are the current solutions running, and how can we extend and expand this thing? So we read a lot of the code. I recall one of the most profound quotes that I have read from the book, which is called Code Complete by Steve McConnell. So that's I think probably the book is 25 or 30 years old, something like that. And it has this quote where it says you read code much more often than you write it. And so optimizing for the write speed is a false economy in general. And this doesn't change with AI. I assume that we're going to talk a lot about AI in this episode, right? So AI also reads, or LLMs also read the code, and they can also get confused if the code itself is confusing, right? So code is information, and the quality of the code, how we organize it, is basically how we organize this information. And it affects our ability to move forward, to work with this thing. We have all seen terrible code bases, I presume, over our time. And we probably will not like to admit, but we produced some of those things, and it's a part of the process, right? But I have seen really some terrible cases where you could really see how the quality of the code affects your business opportunity, your opportunity to make some changes in it. There were literally cases where we couldn't do what was asked of us. I mean, we could in very large amount of time. like in years or something like that. But that basically, I like to describe the situation where the code has a mind of its own. It becomes this beast which you cannot really direct anymore, right? It owns you. You don't own your code base anymore, right? And so the quality of the code is really important if we want to produce business value. And I want to stress this because I see even before LLMs, and especially these days, there's this like false dichotomy, which somehow says that like, or I see many people say like, I care about delivering business value. I don't really care that much about code. But these two things are not in opposition. If your code is in a terrible state, then you're failing to deliver business value in the first place, right? So yeah, I would say that the quality of the code really allows us to work with this thing reliably and move it forward because, of course, it's a process. It's not a one-off thing in most cases. And what makes a good code is, of course, I don't think it can be precisely defined, but very broadly speaking, it's about how you organize this information because code is information. So you want to have things like modularity. You want to split things across modules and functions. You want to have like stuff such as cohesion. So the things which belong together should be in a single place. Things which are kind of independent should be separated from each other. So cohesion and loose coupling, right? Then you want to clearly express your ideas when we talk about the lower level, such as that someone reads the code, they should be able to relatively easily understand how is this problem solved. This is to me more important than the correctness itself. Like I have seen correct code which I couldn't understand, and then I cannot do anything about it, right? But if I can understand your code, then I can maybe understand that it's not correct and do something about it, right? So that's more important thing. There's this clarity, right? This is the general idea. So that's in broad terms how I would describe the quality of the code.
If low quality code is making it into, say, a shared code base over time, how does that then impacts the future development of that project, its evolution, its tech debt?
Which is terrible, right? I had situations where I just looked at the code and there was no way I could understand it. So that was before LLMs. Admittedly, these days, LLMs can help a bit with that, or not a bit, they can help a lot with that. But still, terrible code or bad code or cryptical code, really, maybe that's how we should call it, is difficult to move, right? So you end up with a situation where you like fix a bug and then as a result of that, another bug appears somewhere or things like that. You have like this, like you have this ship where you plug one hole and another one pops up somewhere. I've had a bunch of those situations, right? Then there's just this kind of lack of conventions and uniformity. I worked with code bases where we didn't do code reviews, actually quite a lot. And you could literally look at the code and tell like if this code comes from Alice or Bob, just by looking at the kind of a style. That when you don't have like this kind of conventions, then anyone else who joins the team is gonna plug their own conventions because why not, right? And this just leads to this further entropy, if you will, of the total code base. So I think that we have to pay attention to the quality of the code before it's actually merged.
Well, Goatmeyer conference last year, you gave a wonderful talk about a theater of PRs. And if y'all haven't watched this talk, or if you weren't at Goatmeyer, I suggest go and find it. It's a good talk, and Saša keeps it interesting. If you could help us understand the theater metaphor there, and what is the performance that everyone is putting on this world stage, and who is that audience?
So the talk is titled "Tell Me a Story." The theater metaphor was actually what's the word that I'm looking for? Made, I suppose, said or written by Max McClure, So Max saw this talk live and then wrote a blog post about it. I think we're gonna hopefully link both the talk link and the post itself. The nice thing or interesting thing about this talk is I gave it 5 times, I think, last year. And the first delivery and the very last one was in a theater, right? So I wanted to do, this was my first time talking in a theater, and I wanted to kind of do something about it, honor the beautiful stages. And so I made like a little bit of theatrical. I like to call this talk a monodrama. It's a 1-hour talk, but it's fun. personally, for me, it's the best talk that I have given, my favorite. So, grab some popcorns, maybe some drinks, and some friends or teammates, and watch it. It's fun. But there is a theater metaphor in it, actually, or I talk about this theater of pull requests and code reviews, right? So the whole idea is like, my feeling is that there is a lot of this just superficial shallow ceremony in code reviews where we basically just kind of read this code, maybe make a couple of comments, and then we LGTM this thing without actually properly understanding. Like the question that the talk asks is like, do we actually make a significant difference there with those code reviews? Like, why are we even doing code reviews? In many teams, nobody ever told me like, what is the purpose of a code review? Like, is there some list defined? Like, what are we trying to achieve with this thing? No, we just assign the thing, and then someone makes some comments about, I don't know, this doesn't satisfy solid principles or whatever, and then you fix this thing, and then they approve, and now we're good to go. There are, of course, a bunch of reasons for that, but I argue that really two big problems are we make too big pull requests, which are, in my opinion, impossible to properly understand. And as a result of that, the reviewers are either going to LGTM it or they are going to make a couple of low-level nitpicky comments, so they kind of get a feel that they made some contribution. Right. And then another problem, and that is really a big problem, even when the pull request is small, is that authors frequently just don't tell the story in incremental steps. They don't use commits to tell the story. Right. So either most often you get like one commit, like implements the entire feature. And the problem is that is like the bunch of different changes are in the feature, and then understanding this is difficult because like I read the diff, and then there are like a couple of lines of code related to some refactoring. A couple of lines of code add some new field, then more refactoring. And it's all presented in a single thing. It's all like intertwined and tangled together. And it's very difficult to understand, right? I had problems understanding pull requests, which were like 100 lines long, because a bunch of different stuff was just crammed together. So either you get like this one commit or you get like a bunch of stream of consciousness commits, where people just kind of commit randomly. You have titles like foo, bar, buzz, blah, make it work, make it really work, make it really, really work, the famous walk of shame. And so I think like predominantly in our industry, we don't pay attention to the history of our commits, right?
Sounds like vibe commits.
Precisely. So yeah, basically, the talk would be condensed into the elevator pitch, like make small pull requests. A pull request doesn't have to implement the entire feature. I frequently split the feature across multiple smaller pull requests. Sometimes I can see this up front, sometimes I don't. I just work on the thing and I see like, okay, this is becoming kind of largish, so I should look where can I wrap it up and submit this thing. I'm going to write in the description like, this implement parts of the feature, this is what I implemented, this is the roadmap, a couple of bullet points, and then that's going to give you like the basic idea. And so you can work on that while I resume working on the follow-up, right? And I pay a lot of attention to making the commits tell the story incremental. I'm not perfectionist about it because that's counterproductive, but you can do a lot with very little or very simple tools. Like the one thing that I mentioned in the talk, work in small steps, right? So think a little bit about like, how am I going to approach this? That's basically how you do work anyway. You cannot implement everything at once, right? So you think about like, what is my next step? And then you implement it and you commit it. So what is the follow-up step? And then you implement that. And moving from there, you basically get already like 80 to 90% of the nice history. I sometimes, when as I'm working, of course, I realize, I don't know, I should have done this earlier. Like maybe I chosen a bad name or something like that. And so I try to amend the history if it's simple. If I get a merge conflict, then I'm not going to bother. But the whole idea is that like the history doesn't go in circles, that's kind of difficult to read. So I try to keep it like ideally straightforward from point A to point B. If there are some small deviations, that's fine as well, right? So that's the general idea.
And with the use of LLMs and the extreme volume of code coming out of AI usage, are we seeing more of this theater of pull requests, this kind of rubber stamping and reviewing?
okay, first and foremost, like I use a lot of AI. I may come off in this episode as a sort of AI skeptic, but so for the record, I use it quite a lot, of course, and I think that these days it's probably like at least 95% of my code is wiped, if you will. So hopefully we're gonna touch on those subjects, right? With that in mind, at least looking at like a bunch of informations or posts on social media, thoughts and blogs and whatnot, I have a feeling that we have been given this magical pill, which makes it possible for us to be much faster at the expense of quality, right? So we just, when I just see the texts that are coming out, the posts, even the code, I can think of only 3 words, slop, 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 right? So I know that this thing makes us faster, but if it makes us faster at the expense of quality, that's not necessarily a good thing. And it feels like at least the people who are loud about it have kind of lost the balance here, right? So yeah, I definitely agree that I think that we get a much more of this theater of PR, right? So how does it even look like? People wipe, right? So teams wipe. So they I don't know, they write some specifications, some markdown thing. They have like this probably harness which builds the entire thing. So you have whatever, I don't know, multiple agents. One is the architect, another codes, and then there are like some who reviews. And everyone says like human is supposed to be in the loop, right? But so like this machinery, for the lack of more explicit word, produces like spits out, I don't know what, thousands of lines of code. What is going to human do in the loop? Like when you give me thousands of lines of code, it's like I can either say I cannot do anything about it or I can LGTM it, right? So it's too late.
I heard a hot take the other week of we shouldn't even be reading the code anymore.
Sure, if you want to do it like that, I suppose. That's one way of doing it. But like, I mean, I feel that the quality of software is going to degrade or is already degrading. Like when I go to these web interfaces of, I predominantly use ChatGPT and Claude, I see a bunch of these small bugs in the most obvious of places, right? So it's not some obscure functionality, and then like Claude Code, So Claude Code, we had recently, what was it, about a month ago or so, there was this big leak of its source code, right? So I like to think that maybe LLM itself wanted to leak it, so it spread around, so it's a proof that it became self-aware maybe. But, bad jokes aside, so like what we know from that leak is that there are like 500,000 lines of code in Claude Code. I'm going to wave my hand a lot here, but it seems to be a bit on the high side, and I'm kind of skeptical that there is a lot of slop there. And in general, I have seen people complaining about a lot of duplication in the wiped code, a bunch of multiple different implementations of similar things. Then there is the thing that if you go to like GitHub of Claude Code, right, you're going to see about 10,000 issues. I mean, I wonder, I don't know, don't they use agents for that? So aren't agents supposed to like fix this thing automatically? Do like developers Anthropic, they get like just pro subscription? They don't have Max or whatever. But, again, bad jokes aside, 10,000 issues, 500,000 lines of code. That's like one issue every 15 lines of code.
Episode right there. We're good.
I think I rest my case. I'm going to let you connect the dots. Yeah, I mean, and this is like the poster child of vibing, right?
Yeah, absolutely.
So like, do we want to do it like this, or maybe there are other ways, right? So I vibe, but I vibe in small steps. I vibe in micro steps, So I don't know. Do you want to talk about that, or do you want to take this conversation elsewhere?
I think that it makes sense right now to kind of go into talking about, well, if we have this volume of code, if we have all these agents doing all of these steps, then what does it mean to have a human in the loop? And what does it mean to still leverage, let's call these power tools, going from a handsaw to a circ saw or something, or a table saw? How do we leverage these power tools to effectively produce high quality code, or even improve the code that we're delivering and shipping, not just maintaining at a higher volume?
circling back to that talk that we mentioned, the point of my talk, and I was myself kind of worried, we are trying to figure out this AI thing, and I'm doing this talk in just at the time where vibing becomes a thing, right? So I was preparing it around February last year. First delivery was April last year. Goatmire, which is the best version, was in October, right? Many things have changed in that period and since then as well, right? So I still think that we predominantly produce too much stuff to be reviewed. That was true before AI, and now with AI, it's just hypercharged, right? So if we want to be kind of responsible and, want to do things in a better way, I think we should kind of maybe take a step back and think about how can I use this tool to provide some quality work, something that can actually be worked with further, something that has less bugs, less security issues, less injections, and whatnot, right? And I always come back to this, what I said in the talk, work in small steps, right? Because whenever you give me thousands of lines of code, this is barely reviewable, if not unreviewable, really. And going above that is really even worse, right? And I honestly don't see reading all those texts about harness, how a human can be in the loop when we basically, produce so much in a single thing. So I think we should work in smaller steps. So make small feature, make small commits. The way I typically do it myself is these days, I basically keep it on a tight leash. So I don't wipe a thing, the whole thing, right? I basically, I don't know, it's probably not called wiping, but wipe is such a cool word, so I use it. I just do one commit at a time, and there will be at least one prompt per commit. And my commits are like micro small. There is the repository, like if you watch the talk or read that blog post, you're going to see one demo repository. And I will also send you a link to one pull request, which I did I think 6 years ago for Oban. Actually, Oban people, Parker and Shannon, they saw my talk. They came here to my home city to give a talk, and they saw my own talk. And then Parker remembered that I did like a pull request, which is non-trivial. So that's like a more real thing. I did a non-trivial pull request for Oban, and it's actually split also in these smaller commits. And so you can study the real case, right? And so like I do these small commits, and basically I would make like a 1 or 2 or 3 prompts, right? So I would say like, write me a gen server, for example. So let's make it more concrete. I did like recently a thing. It's called an SMPP. So this is like some network protocol, doesn't really matter for this story. There is a library which you use, and then on top of this library, I have to implement some behavior. And so I said like, okay, implement me the basic thing, the most minimal thing that connects to the other side. And write me a happy path test. And that's what it did. And then I said, write me a test when it's not connected, and that's what it did. And so that was like maybe 20, 30 lines of code or something like that. Commit. Next prompt. Okay, so now we actually have to send it is called a bind message. It's kind of like a login, if you will. I send some credentials, and then it's going to respond asynchronously. So write me this basic thing which just sends something. And then we had to actually implement a mock remote peer. And so I told it, implement the basic mock remote. I added like an example of how I want to use it in a test. So the usage examples. And so again, I got like maybe 20 lines of code, commit, and then now we have to send a asynchronous response. Send me successful response. Write me a test for that. Commit. Send me an error response. Write me a test for that. Commit. And so these are such small steps that I can always look at the code quickly. I can understand it quickly. Very frequently there have to be some tweaks. It can go like kind of make some more complications, so to speak. It makes things more complicated. And when I work in those small steps, I can quickly see it. I usually then don't ask it to fix it. I just fix it myself. I say like, okay, I made some small tweaks, small simplifications, refresh your context, move along. And it's a nice, smooth session. When I do it like this, one time I actually tried it with Haiku, and it was working. You don't actually have to use like these expensive models necessarily. I would necessarily say that Haiku is always good. Sonnet will probably be fine. These days I'm mostly more on Codex anyway. But when you do it in these small steps, it has less room to get lost. right? And it gets lost quickly, no matter how powerful it is.
Right. So hearing keeping it small, single responsibility principles. So do you think pull requests as we are using them today still make sense in the age of AI-assisted workflows? Do you think it's even more important in the review process itself outside of keeping the commits small? What are your opinions?
Yeah, I think pull requests are always important because it kind of gives you a rounded story of what you're bringing to the main branch, right? In that context, it is always important, even if it is terribly done. If nothing else, you can easily revert it, right? So there is like a side discussion here or side point, which is whether, like when we're merging, whether we should be using explicit merge commit with two parents or whether we should squash merge or rebase. And for the record, I want to say merge commit is the way always, and this is the hill I'm going to die on. So there's like zero discussion about it, right? But anyway, when you merge this thing, when you have like pull request, it's a unit of change which is brought to the main branch. And of course, it is a place where we can gather and discuss like these approaches and these ideas. I think that code reviews always make sense because human has to be in the loop. And so human has to understand this thing. And ultimately, we have to approve, are we going to let the AI just do this thing autonomously? I don't think we're there yet. I don't think we're nowhere near there yet. But like, I mean, if we do that, maybe I'm going to stop using software altogether, if possible. Yeah.
Let's talk a little bit more about using LLMs when it comes to the test aspect of what you're introducing into a PR. Sounds like you're focusing on just kind of telling it what specific tests to write in terms of like what scenario to test, like test the happy path, test this particular problem, test this particular problem. Do you keep that pretty scoped? Do you use the same tool that wrote the code under test to write the test code? Or do you use a different LLM for that? How do you seem to get better results versus other approaches?
I use very low tech setup. I just have a single session and that's where I do my thing. And maybe then I just reset the session when I want to reset the context. I think that for what I was reading on social media, that Zach Daniel of the Ash framework and that Chris McCord also, they don't have like these elaborate setups and whatnot, So hopefully that gives me some sense that I might be on the right track, that there are like other people. So in general, when you talk about tests, so I have been reading a lot of like rave reviews, like LLMs are great for writing tests. I have found them to be like relatively underwhelming in that regard. Same thing or even worse for documentation. Though I have to say, I'm sorry for being mean here, but given the kind of quality of test and documentation that I have seen in my lifetime, I can understand why people praise LLMs, but that's saying more about how it was written so far than like, yeah, sorry about that. But I'm just going to call it like it is. I think I have reached the age where I can be called an old man yelling at the cloud.
It's a training data problem, maybe.
Yeah, it definitely is. But I mean, like these things aren't critical thinkers, they are like good information synthesizers and they can match patterns and whatnot, But this is why I also think that they are definitely insufficient for reviews. That doesn't mean that they're bad. They can discover a bunch of issues that we wouldn't discover. It's an aid, right? But it cannot replace a human. But again, I'm going to come back to this thing working in small steps. When you work in this really small step, then like, okay, I have added this thing and I should test like this small behavior. I have added another thing, I should test this another behavior. So I frequently separate the happy path from the error path, both in the implementation and then in the test. And then I don't have to worry about much about like which test cases do I have to come up with. They come up as we develop, right? Another thing, speaking of tests, I had a whole workshop, which I'm not giving anymore because apparently nobody's interested because I think LLMs are, they're just going to wipe it everything, right? But I feel that the tests are usually written in a very poor way, in the sense that there is a lot of mechanical noise thrown in there, and the test fails, and I find myself like most of the cases I find myself looking like, what is this test even testing? Why is this test failing? Is it a bug? Is it a problem in the test? And I spend like a lot of time trying to even understand the purpose of the test, because there is so much noise there. Or there is like assertion, something has to be 1, 2, 3. Why does it has to be 1, 2, 3? Where is it written? And you don't find it. It's like buried somewhere in like deep fixture, God knows where, right? And so many people say to me that they don't like writing tests. So writing tests is one of my favorite activity, because tests are the exercise in good, clear, concise communication, and code is communication, as I said. Tests, you have to bring them into very 3 simple steps. Given this, when I do this, that should happen. Given when, then is pattern call. It doesn't have to be 3 lines of code, but it has to be the clear flow, and all the information that you need to understand the purpose of the test has to be there, and nothing else has to be there. And then you basically, what you do is you write small wrapper functions, helper functions, which I put as private in the test case module, and then maybe they go to test support as they have to be reused across different cases. And this is how I evolve my internal test API. And it's such a great experience. And this is how I do it with LLM too. So it writes like this bulk thing, and then I tell it, okay, I actually want it to look like this. Then it refactors, and then we maybe write another test. And once we have these patterns established, then I can maybe give it a bit more space. Like, okay, given this pattern of code of how this looks like, maybe you could cover more functionality with test yourself, so that then you can actually be faster.
Are you using like a TDD, a test-driven development approach with LLMs? And is that an approach that you used prior to using these tools?
That's a good question. Yeah. So I never used TDD. Well, I mean, I tried it, of course, but I just couldn't work like that. My mind is like, okay, I want to first implement and then test. But I do it again in small steps, right? So in terms of LLM, I guess it makes sense to try to do TDD with it if you want to give it more room, right? So if you want to like put it to work for, I don't know, whatever, 10, 20 minutes or more, right? That doesn't happen to me. My prompts take like up to 1 minute or 2 minutes at the most to finish, So give it a larger chunk of work. I can see where it would make sense that it first maybe writes a test and then actually tries to implement it. Yeah.
Yeah, the testing should be the living documentation.
I could probably have a whole episode about tests, but I just feel that in this vibe era, no one really cares, right? Same thing for documentation when we talk about it, right? But yeah, they just have to be very concise. And so one thing that I have noticed with tests, that I think that actually from this limited experience, LLMs, they're like worst areas perhaps in tests. And documentation as well, right? So the thing that I have seen, like I have a colleague who like wiped something and then I review it, and the test part was really where it was terrible, right? So the tests were taking too long. It actually tested some internal implementation details which were completely irrelevant. It didn't test the behavior. That's one thing that I heard. There's this powerful talk. It's called TDD. Where did it go wrong? By Ian Cooper, and Ian said in this talk, like, test behavior, not implementation details. And this is a very powerful, very important statement. And like LLM went all over the place. It didn't use different timeouts in test environment. And so tests for this relatively small service were taking like 15 seconds. It generated modules dynamically for each test, like unique module, which was completely unnecessary. And that's like Opus generated code, right? So we're talking about the prime thing here. What else was in there? Some compile time macro magic, which was needless. Using agents where you could use just plain data structure, and so on. Oh, and my favorite was there was like a block of tests, the like describe block, I think, which was about telemetry. And it added if, so only run this test if telemetry module is available, but it was not available because the telemetry was not added as a dependency, so you shouldn't even do it. So like those tests were not running at all, right?
Yeah, I've seen a mess in the tests from LLMs. Tests that, like your shirt, they're always right, but there's nothing to them. They're hollow, or a lot of duplication. And
yeah. I think we're kind of just trying to throw, like, I see that people are trying to throw mutation testing. Of course, it helps, right? But what it really helps is also critical thinking. Human reviewer who actually like can see this and they can spot those problems if they are given reasonably small amount of information to review. So working in small steps has always been a universal advice for anything, really, not just programming, right? So yeah, I think that we really need to be more working smaller increments. That's the agile approach after all, and still keep humans.
I've seen that too, just verbose, hyper complex, or I've had the issue where I'll ask it to fix a failing test and it fixes the test so that it matches the failure. It's like, oh great, that didn't help it. I guess the test is passing now, right? So in this age, can AI even know what good code is, given that sometimes goodness is contextual to a team and a code base? What do you think?
Yeah, I don't think we're there. I don't think we're there. I don't really see it becoming there, going there anywhere. So like, this is not a critical thinker again. It's basically a fancy pattern matcher. It's great, to be clear. But I have found whenever I kind of ask it to review something for clarity, whether it's code or text, it was mostly a mixed bag. And ultimately, I just gave up doing this because it spends my mental potential or mental energy just reading those things where like, okay, this actually doesn't make sense, this maybe makes sense. I didn't really find I was getting a lot of benefit from that. It didn't spark joy, if you will. And so I personally don't think that AI is good reviewer in that sense. I think it's great in finding bugs. So that was really, it found like some problems, edge cases, things that I wouldn't notice that maybe were not even covered by tests. So this is where I find it's really good. But as in terms of code quality and clarity, no, I think that this is really precisely what you said. It's about, knowing the whole context. It's about having this professional experience, if you want, also what works, what not, in which situation. Like, I mean, big part of code quality is that you want to have solutions which are neither over nor under engineered. And like that depends heavily on the given context, You want to have this simplicity. People struggle with this, like more junior or even like early senior developers, and it takes time to kind of get that feeling. I don't even know how to describe it other than just, give you a case-by-case example through pull requests.
So what tools, you said you have pretty low tech, simple setup. And you mentioned you're largely using Codex these days. What tools are you using? Do you use Tidewave for Elixir Works? Do you, how do you approach it? And when do you decide this is something that I'm going to write?
Because I'm mostly completely on the backend side of things. I didn't have the chance to do Tidewave, but I would use it. It makes sense to me. Other than that, so when I said low tech, I mean the lowest possible of it all. I don't have skills. Okay, I don't, I didn't have need for MCPs, so I just didn't do it, right? But like those skills, this is also another one of my pet peeves. I was looking at various examples. A bunch of them seems to be wiped. Anyway, I'm just looking at like this markdown list, like what is this thing? Like you're a world-class expert. I think there was one skill for Elixir, which actually said like, among other things, like write code like Saša Jurić. And I was thinking to myself, like, if this thing looks at my open source repositories, like, there's going to be terrible code. People don't write code or don't tell your AI to write code like that. Like, I do have ideas about good code, but not my open source, at least my earlier projects are not necessarily written well, okay? So, yeah, I don't do any of those things. I have like, I just closed my ID, but I think that like my agent's MD is maybe 10 lines long or something like that, very, very very basic things like I have some mix alias which runs on CI, and I tell it like run this thing before you're done, which like checks everything, the formatting, the credo, things like that. I think that these tools are actually becoming more important than ever. So credo, like write a good credo setup with all those styling rules, so you don't have to explain it to the LLM, right? When it comes to manually writing code, I pretty much ask, like if I have to implement some chunk of code, I'm going to ask the LLM to do it for me. And then when I'm fixing it, I may, usually if there are like small fixes, it's just quicker to simply make the fix manually rather than actually ask the LLM, right? But I still feel, and this is a very interesting thing. So I feel that like in this flow, I'm maybe, it's hard to say 10, 20, 30% faster. Typically when we're talking about building new thing, there are things where LLMs can be bring dramatical improvements. Like, I don't know, you have to upgrade to the new version of Elixir and Erlang and dependencies, and you just do this thing on the side. Like, I would wipe this thing as well, and look at the final result. So that kind of thing. Try to fix me this bug, right? That's also something which I would just give it and see what happens, at least. What else? Like if you're doing repetitive work, you have like 10 forms, you want to build form number 11, which is in the same style and everything, different fields. Like that's where I would wipe it. I would say like, okay, use this form as an example, use this pull request as an example of how I want my commits to be structured, look at the tests, blah, 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 right? But what I want to say is like when we're talking about this kind of non-standard, non-repetitive work, I'm building it in small steps. And what I find more important than speed, we are focusing too much on speed here, really, is that I am very close to the code. I still feel like I'm coding. I'm just not typing every character manually. But what I feel is my mind is not so burdened with all these low details. I don't have to look into the documentation, how exactly to call this function, things like that, right? So the LLM does this thing for me. And it feels like I have moved to just one level above, like typical code. And I find this actually quite refreshing. So it feels like I'm coding, but I don't have to pay so much attention or keep so many things in my mind. So it feels like it's a bit less intense and almost like I could do it for a longer period of times as a result of that. And actually focus more on like the quality of the work, because this is the thing that nobody talks about. Everybody talks about being faster, but nobody talks about like doing better work. Maybe we should do less work better rather than more things faster.
Yeah, you always are given it'll improve the speed of your work by 10 times. You can do 10 times more. And you're saying maybe it's 10%, 20, 30% more, about 10 times. You voiced this in a recent X post that we had stumbled on about some of AI reviewing code littered with issues, which we talked about. Can you walk us through your first impression when you opened that PR? What was the moment you realized that maybe this wasn't going to be a normal review?
Well, it is a normal review, actually, at least for me. It is no, I'm kidding. But it's not uncommon to have this kind of thing, especially if I come with a new team, where they're kind of not used to this thing, or used to like this way of doing that I propose. Usually the feeling is always the same. Like I look through this, maybe start making some comments, and something along the lines of about the comment number 20 or so, I realized that like, okay, this is actually not working, because I'm going to make a bunch of comments, and even if they fix those comments, I'm still not going to be convinced that we're better. I'm kind of just seeing a bunch of like, if you will, death by 1,000 paper cuts, So there was this point, and again, this is something that kind of comes with experience, but there was this point where I feel like, okay, I think the best thing I could do is take this thing and try to refactor it myself, right? And that's what I did in that post, which I think we're going to hopefully also link. So the context of the post was like, I was given this pull request, it was wiped, it was about 1,000 lines of code, it had a bunch of issues, some of those I mentioned with tests. It had a bunch of other issues like too complex state in the gen server. There were like redundant pieces of information that were needless. There was supervisor running under gen server, which was completely confusing, and it wasn't needed at all. Agent was used in some place instead of plain data structure, and so on and so forth, right? So I'm ranting a lot on AI, and so I have to just say as well, this thing was built by a developer who is otherwise experienced but not experienced with Elixir, and there is no way they would be able to produce something like that in a reasonable amount of time. So it does help, really, right? And in general, I would say, given the kind of code that I have seen pre-Vibe, I'm still kind of thinking that LLMs are on average better than humans. Sorry about that. That doesn't mean they're good enough, but I have definitely seen much worse code produced by humans.
It's just a statistical answer anyways, right?
Exactly. Yeah, it's median, right? I suppose. Yeah, but anyway, so like I refactored and I vibe refactor it, right? So I didn't understand this code completely, and I just noticed that I'm making all these comments and I still don't understand it, and I'm not sure exactly what should we do. And so I just so like I'm gonna try it myself, and I fire up the session, and I see one issue, and then like I notice, do we really need this thing in the state? And it says like, oh, it's actually redundant. Okay, let's remove this thing. And again, small steps, you just carve it off. And I do this thing, commit, and like going first. Well, the first thing I solved was like this tests because they were taking 15 seconds, and I wasn't going to have any of that because that slows me down. And so first we fixed the test run, and then we were just, I was just looking one issue at a time, and it just went from 1,000 lines of code to 500 lines of code, right? And so I think that this is a huge saving. And bear in mind that those LLMs, they are human-like. They get lost if the context is too large, as well, right? They start to hallucinate more or just simply ignore things that you tell them, even if it's in screaming caps and whatnot. And so, like, you want to keep things simple for them as well, right? So it's pretty much a similar thing. So whoever says they don't care about state of the code, I think basically is just trying to get fast to the market and grab some cash. I'm sorry for being cynical and blunt, but I cannot see it any other way. That code has to be in a good state so we can actually move this thing forward.
In your Tell a Story talk at Goatmeyer, you had mentioned telling the developer when reviewing code that it was unreviewable was also an option, which might be controversial compared to maybe some developers that are like, oh, got to find something to nitpick. Looks good to me.
There's like so obviously, of course, you don't say it like that, right? Your code is unreviewable or this pull request is unreviewable. You could say like, I have problems understanding this. This is too big for me. Things like that, right? There is like, I know it's hard for everyone. It's hard to admit like I cannot understand this thing, right? You feel like a failure. But honestly, just making some nitpick comments and then LGTM is not going to cut it, right? So, like, I think we should do this more. Of course, obviously, in a somewhat nicer way. I typically do this. I also mentioned it in the talk, as far as I remember. I typically also reach out to the author then, and so I say like, okay, this thing is too big. I don't know what to make of it. Like, can we somehow make it smaller? And if I have the time, I'm going to, because this is my role after all. I'm going to actually help them do this. I had one great example. This was like, so the first pull request in the project, Greenfield project, right? 4,000 lines of code, a bunch of stuff, it was a big form of maybe 20, 30 fields. It solves problems that don't even exist yet and whatnot. And I told to the colleague, like, you made legacy in the very first pull request of a Greenfield project. This is already legacy, right? And so we just sat and paired for a day, or maybe even less than that. And what we did was like, there are like, I don't know, 20, 30 fields. I said, we're going to use just one field, ID. Okay. He was puzzled. Okay, but doesn't matter. We just need one thing so we can implement CRUD, right? And then we're going to add like a group of fields, like maybe personal data, and so that's like a smaller group, and then we can add that, and then you have like these validations because you have to read through these validations. So we kind of build slowly, you don't have to, if you have this mega form, you don't have to crunch it all in one piece, right?
It's easy to miss key details too when you're doing so much all at once. And how do you make sure you've actually covered all of the functionality you need to test in what you just built in 4,000?
This reminds me, like, after I gave this talk last year in Chattanooga and Geek City Elixir, so Maggie and Bruce hosted me. That was a really fun experience. And then I was like the closing keynote of the whole thing. And one attendee came to me and said, like, thanked me for the talk and said, like, they get these huge pull requests and it takes them like 5 hours to review. And then I was like, first of all, I would quit my job. I don't know what they're going to do. I play guitar as a hobby. I'm gonna play on the street, whatever. Like, there's no way I'm gonna do these 5-hour code reviews as a regular time thing, And I don't know. No matter how much concentration do you have, like if it takes so long, I bet you there are like a bunch of things that you have missed. It's just too huge. It's kind of like, I'm writing a book and give you like this 800 pages, War and Peace size. Like, there you go. Can you review this thing for me? It doesn't work like that. Publishers are not going to accept you writing the whole book and submitting it like that.
So what would a good AI workflow look like to you? If it was the ultimate, if you could be the one determining the workflow?
I use it as a tool, as a side tool, right? So it's a powerful, very powerful tool. But I feel that at least the loudest members of the industry currently are kind of just use it as this whole thing that just spits out a bunch of code and crunches feature. Basically, they are becoming like the coders and testers and whatnot. I don't use it like that. For me, it's a tool. And so basically, what I said earlier, it's just this very low-tech setup. I just fire up the session. I ask it to do something for me. I discuss things with it. So I implemented this SMPP protocol. I didn't know anything about it. We just, discussed it in this session. I asked it, like, give me a very high-level overview, then let me what I have to implement next, and this is how it works. I think really more important than all these tools, the fancy tools and integrations and whatnot, is not forgetting that we have to work in small steps. And I always keep coming to that, but this is really the idea, because that's the agile way, and the agile way basically means that you don't have to design everything up front. And this is really difficult to do anyway. This is why we went from, I think, big design up front to the agile approach of working in small increments, getting some feedback, reflecting, and moving along. At least that's how my mind works, and it has always been working like that for me. We seem to be heading popularly in this waterfall direction. I am somewhat skeptical about the quality of the output. It's hard to predict what people are going to use, because we are basically greedy. Everyone is greedy. Everyone just wants to do more things faster and grab more cash faster, right? And I will not be surprised if it just goes down that path. But as I said earlier, I feel that the software quality is going to suffer more and more. I am somewhat grateful that enterprises tend to be more conservative. So, probably banks are not vibing still much. And so my money is hopefully safe, right? But going back to the original question, I'm currently in fan of just, using it in a very low-tech way. I fire up a session, I ask it questions. These are typically small prompts, like 1 or 2 sentences, occasionally a code snippet, like this is what I want, make me this thing, and then reflect. I don't allow it to commit. I commit myself because it's an easy thing anyway, and I typically don't let it work much without control.
I think that's a good note to end on, is remember the lessons that we've learned over the many years of evolving our craft of writing software, of working in manageable chunks and iterations, and but leverage the tools that exist for you. Saša, do you have any other final plugs or messages you want to leave with the audience?
Yeah, as I said, work in small steps. Take a look at the Goldmeyer version of Tell Me a Story. There is a transcribed version. I would also like to mention a wonderful book by Adrian Braganza, which is called Looks Good to Me. It's about, obviously about code reviews. It's a lightweight read, but it's a very important read that kind of systemizes a bunch of different aspects about code reviews. So take a look at that too. And I'm going to send you also an example of my Oban pull request, which is a real-life example of this kind of philosophy that I'm talking about.
Great. Thank you so much for joining us. Our guest is Saša Jurić, and we'll be sure to put in the show notes links to the talk, Tell Me a Story from Goldmeyer, the X post we've been referencing, the book, the Oban PR, and more. So thanks for joining us again, and we look forward to next time.
Thank you for having me. It was fun.
Elixir Wizards is a production of Smart Logic. You can find us online at smartlogic.io.
Don't forget to like, subscribe, and leave a review. This episode was produced and edited by Paloma Pachenik for SmartLogic.
Thanks for joining us, and we'll see you next week for another episode of The State of the Stack.
Hey, this is Yair Flicker, president of SmartLogic, the company that brings you this podcast. SmartLogic is a consulting company that helps our clients accelerate the pace of their product development. We build custom software applications for our clients, typically using Phoenix and Elixir, Rails, React, and Flutter for mobile app development. We're always happy to get acquainted, even if there isn't an immediate need or opportunity. And of course, referrals are always greatly appreciated. Please email contact@smartlogic.io to chat. Thanks, and have a great day.